Alright, so in this video, we're going to be looking at inequalities and their graphs. So quick scenario, let's say you walk into a store with $50. Do you have to spend exactly $50? Well, the answer is no. Well, how much can you spend then? Well, you can spend up to $50 or at most $50. But you could spend $30 if you wanted to, depending on, of course, what you were interested in buying. So in this video, we're going to be writing inequalities, identifying solutions to inequalities, and then also looking at the graphs of inequalities. So looking here, we have W is less than or equal to 5. Now, we're going to be looking at which numbers are solutions. The list will come up here in a second. But first, quick definition. A solution to an inequality is any number that makes the inequality true. So, is 8 a solution to this? Is 8 less than or equal to 5? No, 8 is bigger than 5. What about 3? 3 is right here on the number line. 3 less than or equal to 5? Yep, 3 is indeed less than or equal to 5. What about 7? Nope, 7 is not less than or equal to 5. 4? Yep, 4 is less than or equal to 5. What about 6? Nope, 6 is not less than or equal to 5. What about 5? Well, indeed, 5 is less than or equal to. It's the or equal to 5 there. In fact, any of the numbers on this side to the left of 5 are going to be a solution to W is less than or equal to 5. What about X is greater than 2? So here's our number line here. Is 0 greater than 2? Nope. 1 greater than 2? Nope. Is 2 greater than 2? Actually, 2 is not greater than 2. 3 is, 4 is, 5 is greater than 2. In fact, any of these numbers to the right of 2 are greater than 2, but it doesn't include 2. It can include 2.01, 2.001, but as soon as you hit 2, not going to be a solution. Y is greater than or equal to 6. Well, we know 6 is greater than or equal to 6, and then other numbers that are greater than 6 are 7, 8, 9, 10, or any to the right of 6. What about Z is less than 8? Well, there's 8 right there. We know 8 is not less than 8 because it's equal to, and so we're not going to include 8 with our solutions, but numbers that are smaller than 8 or less than 8 are going to be to the left of 8 on the number line, not including 8. So 7.9, 7.99, 7.9999999 will also work. Here we're just going to be writing these out. So numbers that are less than or equal to -7. Well, numbers, well, those can be any number, right? So we're just going to use n. You could use x, whatever your teacher wants you to use for this variable here. Are less than or equal to. Well, that's going to be this symbol here. It's the less than symbol with a little line under it, meaning or equal to, and then -7 written like that. 5 less than a number is greater than 3. 5 less than, what does that mean? It means subtract 5. 5 subtracted from a number, we'll use n for a placeholder for whatever that number might be, is greater than, is going to be this symbol here, then 3 goes there. So this one here is a common, it's kind of some tricky wording. So less than and is less than are different. Or you might also see it are less than if you're talking about numbers that are less than. So this is less than or are less than or equal to, and strictly saying less than is a -5 there. So that's the difference between less than and is or are less than. All right, so go ahead and pause the video and give these a whirl and then come on back. So here we go. Numbers that are greater than or equal to 5.3. So numbers greater than or equal to 5.3 should look like that. Letter B, the sum of B and 5 is less than -3. So sum of B and 5 means B plus 5, right there, sum of B and 5. And then is less than that symbol right there, and then -3 goes there. All right, identify solution by evaluating. So is the number, in this case -2, a solution to 3x plus 2 is greater than -1? So remember, our solutions are numbers that makes the inequality true. So we're going to do this by using substitution or evaluating. So we start with our original inequality, and now what we're going to do is we're going to switch our variable with the number that we are trying out. In this case, that's going to be a -2. And what we're doing is we're going to do our order of operation to see if it is indeed greater than. So here we go. So we'll start out by doing the multiply step. So we have 3 times -2. Positive times a negative is negative. 3 times 2 is 6. And then we still have the rest of it. And again, we're still checking to see if it is greater than. So now we do the addition step. -6 plus 2. So we're subtracting 6 from 2. And that's going to make a -4, which is not greater than -1. So with these, you can also think money. You have to pay $6 or you owe $6. You only have 2. You're still going to owe $4. Now, the numbers here might be a little confusing as well, but if you think temperature, which is warmer, 4 degrees below 0 or 1 degree below 0? Well, 1 degree below 0 is warmer or greater than the -4 or the 4 below 0. So -4 is not greater than -1. So -2 is not a solution. So go ahead and try the value 2 and see if that's a solution. Pause the video and then come on back. So we're going to start out by substituting. So we're going to replace the x with the value that we're trying. In this case, it's a 2. And then we're going to do our order of operations to see if it is indeed greater than -1. So start out with a multiply step, 3 times 2. Then we still have the plus 2, checking to see if that's going to be greater than -1. 6 plus 2 for addition makes 8, and 8 is indeed greater than -1. So 2 is indeed a solution to the inequality 3x plus 2 is greater than -1. Okay, now we're going to move on to graphing. So the graph of 2 is greater than or equal to a. So we're not used to actually seeing it this way. So if 2 is greater than or equal to a, that means that a is less than or equal to 2. So this is the way that we're used to seeing it, with the variable first. If it's written the other way, at least in your brain, think of it this way. So we know that 2 is our border number. That's where it starts or it ends, if you want to think of it that way. And the is or equal to part of it means we're going to have a closed dot on our graph when we go to graph this. And then we're looking for numbers that are less than 2. Those are going to be on the left of 2. So we're going to shade to the left. And this is how we go about graphing solution sets to these inequalities. So another example here, we have a is less than 4. So on our number line, when we go to draw these on pencil and paper, we need at least 2 numbers. We want to have a 0 on there, so that's kind of our reference point. And then we put any other important numbers on there as well. So a, or our numbers, are going to be less than 4. And so in this case here, 4 at the spot on our number line where we have the 4, that's going to be an open dot. And that means 4 is not going to be a solution. And then for less than, those numbers are going to be to the left of 4. So 0, 1, 2, 3, 3.9, 3.99, those are all solutions. All your negative numbers, -1, -2, -3. So go ahead and pause the video and give this one a try, and then come on back, see how you did. So we have b is greater than or equal to -3. So on our number line, on our piece of paper, we need 0, and then any other important numbers. In this case, that's going to be a -3. So since it's an or equal to, that means -3 is a solution, so we're going to use a closed dot with that one. And then the numbers that are greater than -3 are going to be to the right of -3 on our number line. So that's what our graph should look like there. Now we're going to be going the other direction. We're going to be starting with the graph and then writing the inequality that goes with the graph. So here we go. So we know we have a closed dot at -1, so that's going to be an or equal to, because -1 is a solution, and then it's shaded to the left, so that means we're going to be using a less than symbol. So here we have our x, our variable, n for numbers, a if that's what you're supposed to use for your inequality there, or for your variable. And then it's shaded to the left, so that's a less than, and it's closed dot, it's a shaded in, so we have the or equal to there, and then our border number is going to be the -1 there, so x less than or equal to -1. So go ahead and try this one out on your own. Pause the video, come on back, see how you did. So we know that -2 has an open dot, so it means -2 is not a solution, so it's going to be strictly greater than or less than. There's going to be no equal to on there. And then shaded to the right means we are using the greater than symbol for numbers bigger than. So here we go. There's our list of numbers, our variable placeholder, greater than because it's shaded to the right. And since it's an open circle, it's not or equal to, it's just strictly greater than, and then our border number there, -2. So here's some phrases that we will see with these inequalities. The first few are pretty simple and straightforward, less than or fewer than, and greater than or more than, and those are going to get open dots or open circles there because they're strictly less than or greater than. And then for our or equal to, sometimes the wording on these can get a little bit tricky. So this symbol is the less than or equal to symbol, but it can also mean at most or no more than. So we're using most and more for a less than symbol. So we do have to make sure we're understanding the meaning of the phrase and not just looking for less or more or something like that. And then for greater than or equal to, that could be at least or no less than. So I want to spend no less than $5, and I want no more than 5 movies in a day. So and then when we have the or equal to, that's going to be closed dots there.